Module 9 covers surface area and volume of solids. When we say solids, we're referring to three-dimensional figures. For example, the volume of this paperclip holder is going to be how much space it displaces. In other words, if you think about the bathtub, when you take a bath, the water in the bathtub is at a certain height. When you sit in it, you go down, but the water rises. The difference between the high point of the water and the low point of the water is going to be the volume that you take up. Same thing with this. It has volume. It takes up space. The surface area is how much you would take to cover all the surfaces. So think about if you were to gift wrap it, how much wrapping paper would you need at a minimum in order to cover all the sides of the rectangular prism that makes up this figure. But I have digressed into long explanations we don't need to get into yet. Instead, let's focus on lesson 1, which is volume of rectangular prisms. The textbook claims that this is going to be a super quick lesson. They say 90 minutes here. That's strange. I thought they said half a day a minute ago when I looked at it. So let's get on with it. Name some objects in your classroom that have volume. Well, for starters, you do. Your pencil does. Your laptop or iPad does, depending on what you're using to learn with. Everything that takes up space has volume. And question asks, how do you think you might be able to determine the volume of those objects? Well, it depends on the objects. Something like a rectangular prism is very simple to determine the volume of. To determine your volume, that takes a little bit more work. When you need to make room for your next book, let's try that again. When you need to make room for your next bookshelf or your new guitar amp, you may need to find the volume, how much space it takes up. The volume is defined as the amount of space inside a three-dimensional object, and you can see right here they're giving you the three-dimensional object of this rectangular prism, where you've got the pinkish side right here, you've got the, I guess you ladies would call that salmon colored side right here, and then you have the golden or yellow side right here. And those different sides make it a three-dimensional shape, giving it volume or space that it takes up. The area is the amount of space that covers the surface of the closed two-dimensional figure. It's measured in square units. So you've got an area of this rectangle, you've got an area of the salmon rectangle, and you've got an area of the golden rectangle. Now, area you can see here is going to be covered in square units. So you can see A for area is equal to square units. Meanwhile, volume is covered in or categorized in cubed units. And if you look at the flat surfaces for area, all you see are squares. But if you look at the volume of this, it's made up of cubes, hence the name square units and cubed units. Moving down from here, in the 3rd century, Archimedes, dead Greek guy, okay, hypothesized that the volume of a solid is equal to the amount of fluid it dispersed when the solid was placed in the liquid. Remember the conversation we had a moment ago about you in the bathtub? That's your volume. As rumor has it, he found his theory when he stepped into a full bathtub and water began to overflow. This concept is what became the practice of using fluid displacement to find volume. There's also a number of common formulas for finding volume. You could use length times width times height for a rectangular prism. You could use 1/3 times base area times height for a pyramid. And you could use base times height for any prism, including the base area, that's capital B for base area, times height for any prism. That includes a triangular prism here. And that's it for that piece of information. We're going to pick up a lot of vocab words in this lesson, the first of which is going to be a three-dimensional figure. A three-dimensional figure has length, width, and height to it. You, too, are going to be a three-dimensional figure. You have length, width, and height. It's just kind of harder to measure on you because you're all roundy and stuff. A prism is a three-dimensional figure with two parallel bases that are connected with polygons. And you can see right here off to the side, you have a prism because it is a three-dimensional figure that has two parallel bases, the top and the bottom here, that are connected by congruent polygons, which are going to become the sides right here. In a rectangular prism, the bases are also going to be congruent, which is what we're dealing with in this prism. Next, volume is the amount of space inside the figure. We've talked about that, also known as the amount of space it displaces, and it is measured in cubic units, which can be written using abbreviations and an exponent of 3, such as units cubed or inches cubed if it's being measured in inches. Continuing on with our explanations, it says you can find the volume of a rectangular prism with whole number measures by packing the prism with cubed units. Decomposing the prism tells you the number of cubes of a given size it would take to fill the prism, and the volume of the prism is related to the dimensions length, width, and height. So in other words, count how many cubes it would take to fill the prism. The rectangular prism shown has a length of 5 units, a width of 3 units, and a height of 3 units. It has a total of 15 units in the base layer of the prism, and it has 3 layers, so the volume of the prism is going to be 15 plus 15 plus 15, also known as 45. Now you can see right here you've got a base of 5 that they said, 1, 2, 3, 4, 5, a width of 3, 1, 2, 3, and a height of 3, 1, 2, 3. So this layer right here is 5 by 3. 5 times 3 is 15, and that's where they got this number 15 for that one layer. You've got 3 layers, so they're going to be the same. 15 plus 15 plus 15 is where they got that 45 cubic units from. Recall now that you learned how to find the volume of a rectangular prism in an earlier grade by using the volume formula V is equal to length times width times height. So apparently you did this back when you were in 6th or 5th grade, where capital V represents volume, little l represents length, little w represents width, and your little h represents the height. And using this method, the volume of the prism would be shown as 5 for length times 3 for width times 3 for height, which is going to give you the same 45 that we found the other way. And with that information, we're going to dive in deeper into learning how to find the volume of a rectangular prism. You can find the volume of a rectangular prism with fractional measures by using different methods. First one they're going to show, they're calling it being method 1, is to use unit cubes. And it says you can pack a rectangular prism with unit cubes. A cube is a special rectangular prism with all sides congruent, and the volume of the cube is found by cubing the side length. It says find the number of unit cubes needed to fill the prism, and each unit cube is going to have a side length of 1/2. The reason they said they have a side length of 1/2 is because you have 2.5 here for a length, and you have 1.5 here for a height. And because they're involving halves, that's the reason they chose half as the length of their unit cube. The length of the prism is going to be 2 1/2 inches. So how many unit cubes would it take in order to get or to fill 2.5 going across? If there are half unit cubes, it would be 5. Now they're showing you 2 1/2 divided by 1/2, because you're divided into 1/2 sections, is equal to 5. Let me take just a minute and give you a refresher on that. If you were to take and divide 2 1/2 by 1/2, we're going to take and keep the first term. So, we're going to change the mixed numbers. Okay, 2 times 2 is 4, plus 1 is going to give me 5 halves divided by 1/2. From here, we're going to keep the first term, change the division multiplication, and flip, otherwise known as take the reciprocal of your second term. We're going to simplify. 2 goes into 2 one times, 2 goes into 2 one times, and we're going to multiply, and that's going to end up giving me 5/1, also known as 5 for how many half-sized unit cubes it would take to cover the length. So jumping back over to our textbook, that's where they came up with that 5 from right there. Next, we have to cover the width. You can see right here the width is going to be 3. So if we take and divide the 3 inches into 1/2 length sides, well, let's jump back over to our scratch paper here, and I'm going to take and divide 3, oh, that doesn't come out very pretty to divide, by 1/2. That's the same thing as saying 3/1 times 2/1, which is going to be 6/1, also known as just 6. And that is where they got the 6 from that you see right here in the unit cubes. So the width of 3 is going to take 6 half-length unit cubes to cover it. Finally, the height is going to be 1 1/2 inches. Using the same process I showed you on the other two, you can figure out that that would take 3 unit cubes in order to cover it. So you're going to have a length of 5 unit cubes, a width of 6 unit cubes, and a height of 3 unit cubes. Next, we're going to take and actually build what we see here. So the base layer, oh, let's see here, where did they go? Okay, that's what they did. The base layer contains 5 this direction, 6 this direction, so that's going to be 5 times 6 is 30, right? And then how many layers of 30 is it? 3. So right here you can see 30 times 3. 30 times 3 is going to end up being 90, so the volume of this is going to be 90 unit cubes. But they're half unit cubes, aren't they? So, wonder what we're going to have to do about that. Let's move on to the next. Now, another formula for volume we've had is that volume can equal to side squared if we're dealing with a cube, which we are here. So each one of these cubes here, like that golden cube you see highlighted there, has a side length of 1/2 unit. So I have 1/2 length, 1/2 width, and 1/2 height. And that's where the 1/2 cube came from, because it's 1/2 times 1/2 times 1/2, also known as 1/8. So each unit cube has a side length of 1/2 inch, therefore the volume of one single unit cube is only going to be 1/8 of inch cubed. You with me so far? They're making this a lot more complicated than it has to be, I'm just saying. But hey, we're going to work with them on it. From there, we're going to take and say that the volume, the number of unit cubes we came up with was 90. Each of those 90 unit cubes measures 1/8 of an inch, and when you multiply and simplify, you find the final answer that has a volume of 11 1/4 inches. And I'll go ahead and show you how they did that. They took and said the 90 times the 1/8. From here, we're going to take and, oops, should be 90 there. Simplify. 2 goes into 8 4 times. 2 goes into 90 45 times. That's going to end up giving us 45/4, also known as 4 goes into 45 11 times with 1 left over. And that's where they came up with the 11 1/4 from for the final object of that shape. Now, yes, it works, but dang it, that's pretty darn complicated, particularly for a 6th grade level. So I'm really hoping method 2 makes a little bit more sense to you guys. And just looking at it, it's going to make a lot more sense. So what do we have here? For this one, we're going to be using the formula that says volume is equal to length times width times height. This is so much easier than the unit cube thing that they had, because what do we know? We know that the length was 2 1/2, we know that the width was 3, and we know that the height was 1 1/2. We can see that on the sides of the cube here telling us what it is equal to. So from there, all we have to do is multiply those things out. So let me take a screenshot of that so we can actually show you how the math worked, because they did just kind of go boom, here's the answer, without really justifying that answer. So let's take and make that a little bit bigger so we can work with it some. And there we go. The 2 1/2, I'm going to take and change that to an improper fraction. 2 times 2 is 4, plus 1 is going to give me 5/2, times that 3, I'm going to make that a 3/1, times the 1 1/2, that's 2 times 1 is 2, plus 1 is going to be 3/2. From here, we're going to simplify, What can be simplified? Absolutely nothing. Nothing will simplify here. So we're going to multiply instead. Well, I'm going to say 5 times 3 is 15. 15 times 3, that's going to equal to 45. Meanwhile, 2 times 1 is 2. Times 2 is going to be 4. And that should look familiar to you because we saw it before. 45 divided by 4, that is going to be the same, 11 1/4 that they came up with working the other way. Jump back over here and you can see 11 1/4 inches cubed is what they put down for their answer. Either method works. I like this method a whole lot better. I think you guys too. This is the method I'm going to be looking for when you do your homework tonight. I'm going to stop this recording because it got pretty complicated as we built into this, and we will come back in just a moment and start working on example 1. I'll see you soon.